Okay, this unit begins the process of proving. We're going to start with just kind of going through proofs of algebra, and then we're going to start into proofs of geometry. Some of it does involve the algebra. Those people that had me last year, some of these are very simple properties. Do you have to write these down? Not necessarily. I think we understand them. Uh, common common one, just for example, is addition. One of the properties of equality is you got x equals 7, where you can add 3 to both sides. Well, that's just addition property. Again, here's another example of subtraction. X equals 10. I can subtract 3, which means I have to subtract 3 on the other side. That goes for the multiplication and division. One that we've talked about a lot also is substitution. Again, do you have to write it down? No. Uh, it says x is 3, and then they give you the statement. So what do? I take out the x and replace it with 3. So see how these are exactly the same statements? All I did was substitute. Whenever I do that, we're just going to call it substitution property. What we're going to do is we're going to break down everything we do into small details. And those small details are going to justify theorems which are required to be proved. Yeah, they're general statements that sometimes totally make sense, but we're going to be able to prove them through some of these processes. It takes a while because we have to get used to the way of thinking. Very first one, we're going to use some algebra definitions. Here we're saying that AB is equal to CD, then BC equals BC. We're going to learn that that's called a reflexive property. It's kind of a dumb property. It's a dumb statement. But basically here, all I did was, as soon as I have these two statements, I can add C to both sides. So basically the justification or property here is addition property. Second one, they're saying 2 times the measure of the angle 72. So if I want the measure of angle 1, I got to divide by 2. See how I divide it by 2? Well, it's just the division property. So basically we're using these algebra properties inside of the context of the geometry. So here we say, and we're saying the measure of angle A is half of x, and half of x is the measure of angle B. Well, we're going to learn that this is actually called the transitive property, which actually is down below. But here all I did was take this statement, this one right here, and I just basically said, I'm going to take out this because I know that is this. So out comes and in comes the measure of angle B. In other words, basically I just took this statement here. I'll erase this so we can see it again. I basically took this statement here, took this out, and replaced it with B because they're equal to each other. So I used substitution property. You can abbreviate these as long as I can understand it. B is in the interior of XOY. So let's draw a picture here. So I've got angle XOY with B in the interior, which means it has to be in here. Well, let's see. That's XOB plus BOY. Oh, that's angle addition postulate. Ah, that's what that is. Angle add property. We've already seen that one before. Here we go again. Remember, it's the same as the segment addition postulate. Now we're using angles. And this last one, I have this. I want to get rid of the plus 2. What do I do to both sides? Is subtract 2, subtract 2. So this has got to be subtraction property. Okay. Flashcards. These are essential in flashcards. Reflexive property. As dumb as this sounds, we're going to have to make these dumb statements where DE is DE. Measure angle 1 is measure 1. Basically, it's a statement requirement in a geometry proof. So we're going to remember that one. It's kind of dumb. Reflects like a mirror. You get the same image back. Symmetric property is when we flip things around. Symmetry means you flip over something. So that's exactly what I'm going to do. BE is equal to AB, I switch the order. AB equals DE. No kidding. If X is equal to 4, 4 is equal to X. It's just, yeah. Again, with angles, it'd be measure of angle 1, which means that measure angle 2. So what I would do is I'd use this, and I'd use these. This part here is your term on one side of the flashcard. Use this as your second side. Same with this one. One side of the flashcard, put this on your second side. The last one is transitive. I can iterate this in a different way. If the number A equals the number B and B equals C, doesn't it follow that A must equal C? That's referred to as the transitive, one side. And here's how it works with angles. They didn't give you segment examples, but here's how it works with angles. If angle 1, measure of angle 1 equals measure of 2, and angle 2 equals measure of angle 3, then that means 1 equals 3. And here's another example, but using congruency statements. Okay, it works with equals and it works with congruencies. So those properties are in both. Okay, here's what we got to do. What we have to do is logically move through a proof. In this diagram, this picture shown here, what we have is a true statement given. Okay, and then we have what we're trying to prove. What we're going to do is think first logically and see how we can go from one to the other. So what I'm going to do is I'm going to first mark down we've got 1 and 3 are equal. Remember, the little slash marks mean equal. And what we're trying to do is we're trying to prove that DEG, that's this angle here, DEG, right here, is equal, let me erase that for a second so we got this down so I can see it better. 1 and 2, and we've got DEG here, and then HEF is here. So if I think about this for a second, let's see. If I know these two are equal, then if I add 2 to both of them, then they must also be equal because 2 is equal to 2. Okay. Yeah, I think that would make sense. If angle 1 and angle 3 are equal, then if I add the same angle, I'm adding the same exact angle and adding this angle to both of them, it should come out to be a true statement. So generally what we're doing with proofs is your first statement, you should have to start with what's given. So see how the given is in statement 1, and your justification or reason for it is given. Now the next thing we thought about when we did this, we said we're going to take the two green angles and we're going to add to both of them this. But before I do that, I have to state that they're the same. And duh, measure of angle 2 is measure of angle 2. I know it's a dumb statement, but if I want to try to add those to both 1 and 3, I have to state that they're equal. And that's that silliness property called reflexive. It's like the mirror, reflective. Okay? Now, if I look at the very first statement here, what I'm going to do is I'm going to add measure of angle 2 to both sides of the equal sign. That's what we do here. So notice how I added measure of angle 2 to both sides. That's why it's addition property. My next logical thing is to say, hey, wait a minute. If I take DEG and think about it, it's actually 1 and 2 combined because I can add angles together. Angle, addition, postulate. And if I take 2 and 3 and add them together, I get that angle. Again, I'm adding angles together. So to justify that statement, I've used angle, addition, postulate because I added angles. And then finally, this always last statement should be what you're trying to prove. Okay. Now I can take this statement right here, number 3. I can take this out because 1 added to 2 is DEG. So I replace it. Now I'm going to take 3 and 2. I know I'm going to take that out and replace it with HF. So 3 is now substituted, and I got that. A lot of things on your last test, we can actually walk through the proofs, and we can do that as additional examples. What did I say goes first? correct. Given. But before you do that, let's think about what they're asking me to prove. They're saying these two pieces are equal. They're saying these two segments are equal length. Well, wouldn't that make sense? That the whole segment would be equal? Now, let's see. Well, if I make sure that these two things are equal and state them, then all I have to do is add equal parts. So I'm going to start with the statement KP equals ST. Well, that's given. Okay. And what I'm going to do is I'm going to notice what I did here, what they did for me. Is they took KP and ST and they added these two things to it. Well, that's adding this like things. That's why you need to write PR equals TV. Besides, they're given and always go first. So basically what I did is I just added the same thing to both sides of the equation. That's addition property. Technically it's of equality, but now the next thing is we wanted to prove this. That should be my last statement. Before I can make that statement, I have to say, wait a minute. Look where I'm at. If I look at this statement, I've got KP plus KR. Well, if I add KP and PR, I get KR. Also, if I take ST plus TV, I get SV. Well, that's just adding two segments together. So I made that statement. I said, hey, I can add those two angles, those two segments together. So segment, I'm adding segments, so it's called segment addition postulate. I've used that one before, SAP. Okay. Then the final thing is we're going to take statement 2. We're going to take this out and replace it with KR. Then we're going to take STTV and replace it with SV by substitution. All right, last one to walk through here. Actually, 2 more. Dang. Okay, here we go. All right, let's walk through this next statement. Start by looking at it, thinking through the whole process. So it says measure of angle 1 is equal to measure of angle 4. Let's see. If I think about this logically, what does 1 and 2 equal to? Now it's a straight angle if I take and add these two angles, so that's 180 degrees. And 3 and 4 is 180 degrees. So if I take the two 180s and I subtract the two equal parts, this one and this one, that should give me two equal parts. So I think I can prove 2 is equal to 3. Okay. So what do I do first? Now, notice they didn't start with the given. It's not totally relevant, but what we do, first statement is, we're going to say this. Well, we're allowed to add the two angles together. Angle addition postulate. We know they add up to 180. The second statement is, we've got 1 and 2 equals 180. 180 equals this. So A equals B, B equals C. That's transitive. So what I did is I basically took this and connected the dots, and I used transitive property. Now somebody could say, well, I'll use substitution. Yeah, you can substitute. You can take this and substitute it in for 180. That would be a justifiable statement. So transitive is just one justification there. Okay, now once I have 1 and 2 equal to 3 and 4, now I can use substitution. See, I can go measure of angle 1 plus measure of angle 2 equals measure of angle 1. Oh, well, wait a minute now. They gave me a hint. Maybe I should use my given. If I use my given, I really just want to state measure of angle 1 equals measure of angle 4, and measure of angle 2 equals measure of angle 3. Now basically all I'm doing is I'm going to take this statement here. I'm going to take off these pieces because they're equal. So subtract property. All right, sometimes the fill in blanks are not too bad because like the given, I just copied down what was given. So this next one, I'm just going to go like this. Not really sure why yet, but I need to think through my problem. Let's see. AOI is this angle. Is equal to EOU. That's this angle. Well, if I take angle 2 out of this picture, from both of them, that's going to leave me with 1 is equal to 3. Oh, that's what I'm proving. So basically what I'm going to do is I should follow through with the idea if I take the whole pieces that they say are equal and subtract 2, it should give me 1 and 3 are equal. Okay, so this is kind of dumb statement, but see, we got to say that. That's reflexive. Remember, that's just look in the mirror, it's exactly the same. So reflexive property. Okay. Next thing, what we're going to do is say, hey, this angle AOI is the addition of these two angles. Angle EOI is the addition of 2 and 3. I added angles together. I did angle addition property. Okay. And now, looking at this original statement, I'm taking this out, going to replace it with what it is. I'm going to take this one out and replace it with what it is. So now I have this statement here by substitution. What's the last thing that should be written? Oh yeah, what you're trying to prove. Measure angle 1 equals measure of angle 3. Well, how did I go from 4 to 5? Well, didn't I just kind of like go eliminate 2 from both sides? Subtraction property. All right, I want you to flip through that, and when you hear this and go through it, I want you to think about what you did not understand so that we can, in class, discuss, can you go over this, or can you give me another example of this type? The next page you'll see is this one. This is actually our practice page. So we want to understand it before we get to the practice page.